step, so we're going to solve. Example A has a plus 7 divided by 8 equals 5. Alright, so what we're going to do here is we got to get the a by itself. It's got 7 added to it, and it's got this divided by 8. Well, the first thing you want to do is you want to get rid of this fraction, just like we were doing in the first examples. So this says to divide by 8. So we're going to do the opposite. We're going to multiply by 8 on both sides. And when we do that, multiplying by 8 and dividing by 8, these cancel one another out. So it is all gone. So on the left-hand side, we're left with the a plus 7. And on the right-hand side, we've got 40. Now it's just like the easy ones from last week. To get the a by itself, instead of adding 7, we're going to subtract 7 from both sides. Oops, hopefully you can tell that's a minus 7. These cancel out. We're left with a equaling our 33. Alright, example B has 2/3 j minus 25 equals 115. Okay, again, the whole purpose is to get the variable by itself. We've got this 2/3 j minus 25. Well, let's get rid of this minus 25. So let's add 25 to both sides. And then we'll deal with that fraction. So if we add 25 to both sides, these cancel out. And we're left with our 2/3 j on the left-hand side, and the right-hand side we have 140. Alright, next. Alright, sorry about that, someone came to the door. Alright, so now we've got 2/3 times j. So to get rid of the 2/3 times j, we are going to divide by 2/3, which really means we want to multiply by the reciprocal. So we're going to multiply by 3 over 2. And on the right-hand side, same thing, multiply by 3 over 2. On the left-hand side, these cancel one another out. And on the right-hand side, 140 times 3 is 420 divided by 2, and we end up with 210 equaling j. Alright, last things. Consecutive integers. What are they? Well, consecutive means in a row, and integers are numbers. So consecutive integers are integers in counting order, like 3, 4, 5. But usually when we're talking about consecutive integers, we don't know what they are. So we'll just call the first number n. The next number is n plus 1 because it's one more. And then the next number is going to be n plus 2. Now sometimes they like to talk about consecutive even integers or consecutive odd integers. If this is the case, if you start with, for example, we'll just start with the number 11. If 11 is our first odd integer, in order to get to the next odd integer, which would be 13, we'd have to add 2. And to get the next one, we'd have to add 4. Okay, so if you're talking about even or odd consecutive integers, you got to work with n, n plus 2, and n plus 4. So let's take a look at this example. It says find 3 consecutive integers with the sum of 21. Alright, they're 3 consecutive, so we're going to use our n plus 1, and n plus 2. Okay, and we are adding these together because it says a sum. So we need to add them together. So n plus 1 plus n plus 2 needs to equal 21. Well, we can go ahead and simplify this left-hand side. We can combine our like terms to get 3n plus 3. Let's get rid of the plus 3 by subtracting 3 from both sides. So now we've got 3n equals 18, and of course we're going to divide by 3, so n equals 6. But do not stop there. That is our first integer. But the problem says find 3 consecutive integers. So if the first one is 6, the next one has to be 7, and the third one has to be 9. So our numbers are 6, 7, and 8, and if you add them all up, yes, they do equal 21. Alright, please put your summary of what you learned today. You should have at least one sentence about each type of example with consecutive